As we covered in the last video, dinosaurs are a diverse group of reptiles of the clade Dinosauria. They became the dominant terrestrial vertebrates after the Triassic-Jurassic extinction event 201.3 million years ago. Dinosaurs are a varied group of animals from a taxonomic, morphological and ecological standpoint and so on. But it's their extinction that I didn't mention in detail, and that's what we're looking at today. All non-avian dinosaurs and most lineages of birds became extinct in a mass extinction event called the Cretaceous Paleogene or KPG extinction event at the end of the Cretaceous period. Above the Cretaceous Paleogene boundary, which has been dated to 66.023 to 0.025 million years ago, fossils of non-avian dinosaurs disappear abruptly. The absence of dinosaur fossils was historically used to assign rocks to the ensuing Cenozoic. The nature of the event that caused this mass extinction has been extensively studied since the 1970s, leading to the development of two mechanisms that are thought to have played major roles. An extraterrestrial impact event in the Yucatan Peninsula, along with a flood basalt volcanism in India. However, the specific mechanisms of the extinction event and the extent of its effects on dinosaurs are still areas of ongoing research. Alongside dinosaurs, many other groups of animals became extinct. Pterosaurs, marine reptiles such as mosasaurs and plesiosaurs, several groups of mammals, ammonites, nautilus-like mollusks, rudis, reef-building bivalves, and various groups of marine plankton. In all, approximately 47% of genera and 76% of species on Earth became extinct during the KBG extinction event. The relatively large size of most dinosaurs and the low diversity of small-bodied dinosaur species at the end of the Cretaceous may have contributed to their extinction. The extinction of the bird lineages that did not survive may also have been caused by a dependence on forest habitats or a lack of adaptations to eating seeds for survival. Just before the KBG extinction event, the number of non-avian dinosaur species that existed globally has been estimated at between 628 and 1078. It remains uncertain whether the diversity of dinosaurs was in gradual decline before the KPG extinction event, or whether the dinosaurs were actually thriving prior to the extinction. Rock formations from the Maastrichtian epoch, which directly preceded the extinction, have been found to have lower diversity than the preceding Campanian epoch, which led to the prevailing view of a long-term decline in diversity. However, these comparisons did not account either for varying preservation potential between rock units or for different extents of exploration and excavation. In 1984, Dale Russell carried out an analysis to account for these biases and found no evidence of a decline. Another analysis by David Fastovsky and colleagues in 2004 even showed that dinosaur diversity continually increased until the extinction, but this analysis has been rebutted. Since then, different approaches based on statistics and mathematical models have variously supported either a sudden extinction or gradual decline. End Cretaceous trends in diversity may have varied between dinosaur lineages. It has been suggested that sauropods were not in decline, while ornithischians and theropods were in decline. The bolide impact hypothesis, first brought to wide attention in 1980 by Walter Alvarez, Luis Alvarez and colleagues, attributes the KPG extinction event to a bolide, extraterrestrial projectile impact. Alvarez and colleagues proposed that a sudden increase in iridium levels recorded around the world in rock deposits at the Cretaceous Paleogene boundary was direct evidence of the impact. Shocked quartz, indicative of a strong shockwave emanating from an impact, was also found worldwide. The actual impact site remained elusive until a crater measuring 180 kilometers or 110 miles wide was discovered in the Yucatan Peninsula of southeastern Mexico, and was publicized in 1991 in a paper by Alan Hildebrand and colleagues. Now, the bulk of the evidence suggests that a bolide 5 to 15 kilometers, 3.1 to 9.3 miles, wide impacted the Yucatan Peninsula 66 million years ago, forming this crater and creating a kill mechanism that triggered the extinction event within hours. The Chicxulub impact would have created immediate effects such as earthquakes, tsunamis, and a global firestorm that likely killed unsheltered animals and started wildfires. However, it would also have had longer-term consequences for the environment. Within days, sulfate aerosols released from rocks at the impact site would have contributed to acid rain and ocean acidification. Soot aerosols are also thought to have spread around the world over the ensuing months and years. They would have cooled the surface of the Earth by reflecting thermal radiation, and greatly slowed photosynthesis by blocking out sunlight, thus creating an impact winter. This role was ascribed to sulfate aerosols until experiments demonstrated otherwise. The cessation of photosynthesis would have led to the collapse of food webs depending on leafy plants, which included all dinosaurs save for grain-eating birds. That's the end of the video, people. If you enjoyed it, it'd be greatly appreciated. Watching more videos and maybe subscribe. It's as free to unsubscribe as it is to subscribe. So, if you've done my videos, you can always unsub. Anyway, I've been Forever Stranger, and this was episode 19 of Slimmer Society.